Hello. Today I'm going to give you a brief introduction to your quiz 4 material. In your textbook, this quiz 4 covers modules 2.1 and 2.2. And this is material that it's not too complicated, so this is a good chance for you to try to stay ahead of the deadlines. So module 2.2 talks about matrix addition and scalar multiplication, and 2.2 is about matrix multiplication. So let me start you up with the ideas on your textbook about matrix addition and scalar multiplication, and let's focus on matrix addition. So important things that you need to remember is that addition on matrices, it's only valid for matrices with the same size. An addition happens entry by entry. So of course, this is a very informal way that I'm telling you this. In your textbook, you're going to see notation like this. So suppose that I'm trying to add two matrices. Let me call those matrices matrix A, whose entries are denoted by Aij, and matrix B, whose entries are going to be little bij. And I'm going to try to add these two matrices. So A plus B is going to be my new matrix, and the entries for A plus B are going to be just Aij plus Bij. By that I mean the entries Ij for this, the addition of my two matrices are going to be component by component. So let me give you an example about this. So my matrix A is going to be, let me just put a simple one, 1, 2, 3, 4, 5, 6. This is a matrix that has 3 rows and 2 columns, so this is a 3 by 2 matrix. And like I said, this, if I want to add it to a matrix B has also to be a 3 by 2 matrix. So I chose 1, 0, negative 1, negative 2, and 0, 2. So the reason why we need the sizes of each of these matrices to be the same is because my matrix A plus B is going to be another 3 by 2 matrix where each of my entries, let me just put them here. This is entry 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 2 are going to consist of, let's see, entry 1, 1. So I and J are 1 and 1. In A plus B comes from A1, 1 and B1, 1. So these two. So 1 and 1 gives me 2. Entry 1, 2 comes from the corresponding 1, 2 entries in each A and B. So 2 plus 0, 2. And so on. So 3 minus 1 gives me 2. 4 minus 2 gives me 2. 5 plus 0 gives me 5. And 6 plus 2 gives me 8. And let me just double check. 2, 2, 2, 2 as well, and then 5 and 8. So yeah, this is how the addition works. And then you see why we require these sizes to be the same, right? My resultant matrix A plus B is going to have the same size, and for you to have an entry in the ij position, it has to come up from the corresponding ij positions there. So that's why we have this requirement of the same size. So nice and easy, this is how we do matrix addition. Let me explain to you scalar multiplication. That's also very easy, but I'm just going to raise the board to have space. Okay, about matrix scalar multiplication, this is easy too. So I want you to remember that by scalar, here we really mean just a real number. And so we denote this scalar in our textbook by S. That's a notation that they typically use. And we don't have any restrictions about the size of the matrix. So let me use the same matrix A that I had before. So I have 1, 2, 3, 4, 5, 6. This is a 3 by 2 matrix. And say in this case my scalar S is equal to 3. This is an S, by the way. So S times A will be just S times this, or 3 times each of the entries. And my resultant matrix is going to be just S times the first entry, the 1, 1, S times the second one, and so on. I still get, if you see, a 3 by 2 matrix. And because S was 3, I get 3, 6, 9, 12, 15, 18. So as you can see by the way that the scalar multiplication works, that indeed it doesn't really require any particular size for A. And it also works your scalar going with each of the entries. So the way that this is represented in your textbook, and again just for you to get used to the notation, is that if I do the multiplication of S times the matrix A, and if I take or figure out what is the ij entry, this is just going to be S times the ij entry of your matrix A. So for example here, this is the entry to 2, and I got this 12 by just multiplying S times the entry to 2. So that's the meaning of this kind of notation. And finally, we're going to go over matrix multiplication. This it's a little bit more involved, but nothing impossible. I do recommend you to practice a lot of matrix multiplication so you get used to that because we're going to need it for the rest of the course. But let me just erase this. Okay, so about matrix multiplication, what things I would like you to keep in mind when you're reading your textbook? The first very, very important thing is that matrix multiplication does care a lot about the size of the matrix. So this is going to be valid only for the situation where the size of the matrices are like this. Say I want to multiply the matrix A that has m rows and n columns. So it's an m by n matrix. And I'm going to multiply times a B matrix. So in general, this is stated as an R by S. But there is a restriction about these two sizes. These two numbers, so the number of columns here and the number of rows of your second matrix have to match. So n has to be equal to r in this case. So once that you check for that, you kind of want to, just as a mnemonic, think that they are kind of canceling out. And your resulting matrix, your matrix A times B, will have the size m by s. Okay? So let me give you an example about the way that these work. So let me start again with the same matrix A as before, just because it's easier for me. 1, 2, 3, 4, 5, 6. So this is a 3 by 2 matrix. And this is my A. If I want to multiply it times a B matrix, it only makes sense to have a matrix that is 2 by something else. So in this case, let me make it into a 2 by 3. So, and I chose 1, negative 1, 0, and 2, 1, negative 1. Because of what I told you here, remember, I do check that these two inner numbers have to be the same. As a mnemonic, think that they cancel. And what I do know is that my resultant matrix AB is actually going to be a 3 by 3 matrix. Remember that in general, these two don't have to be the same. This could be a 2 by 4, and then my resultant matrix would be a 3 by 4 matrix. But I just wanted to give you a simple example. So let's see, my 3 by 3 matrix is going to look like this, right? So this is my term 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, etc. My 3, 3 entry. Let me just give you an example. So if I want my matrix AB, the term 1, 1, this is going to come from the first row and the first column. So this is going to be 1, 2, product with, in this case, it ends up being 1, 2 as well. And I'm going to match them just 1 and 1 and 2 and 2. So this is 1 times 1 plus 2 times 2, which is 1 plus 4. So my 1, 1 entry here is going to be 5. Does that make sense? So let me try this one, okay? This is the term 2, 3. Right? Second row, third column. And this is going to come from this one with this one. So second row with my third column. So this is going to be 3 times 0 plus 4 times negative 1. So that's just negative 4. And that's my term here. So please make a pause now and try to fill the rest of these entries just to make sure that you're understanding. And I'm just going to give you the answer for this just to double check that indeed this is making sense for you. And if at some point this doesn't make sense, go back to the textbook or reach out to me or to your tutors about this, and we'll be happy to help. So after you completed this, you should have gotten 1 here, negative 2, 11, 1. This was 17, 1, and negative 6. And like I said, this is a good introduction for you to the material. Go ahead now and start reading our textbook for more details about that and putting together the notation there with these ideas.